Tonight, what we're going to be talking about is titrations and just going over a little bit with some vocabulary that you're going to need to know in order to do a titration. So what is a titration? Basically, it's just a lab technique that we're going to be practicing in class. And what it is it's used to determine the concentration or molarity of a known reactant. So we know what the reactant is. We know like it's an acid. We know that it's HCl, but we don't know the exact molarity. A lot of times they'll do this to figure out the concentrations of, let's say, iron in water or different things. Okay. All right, so what are the steps for a titration? The first one is that you're going to react a titrant with an analyte. What is the titrant? These are just two different vocabs you're 100% going to have to be able to identify. A titrant is the solution, so you're going to be using two different solutions, two different liquids. The titrant is the solution where you know the concentration and the volume. The analyte is what we are analyzing. So notice that's what I always look at. Analyte is what we're analyzing, so that's what we're going to try to figure something out about. And it is with the unknown concentration but a known volume. So the titrant we know everything about. The analyte is what we're trying to analyze and where we don't know something about it. So for example, let's say I reacted 25 milliliters of 0.56 molar HCl with 50 milliliters of NaOH in this reaction. In this reaction, notice that I know everything about HCl. Okay, so I know both the volume and the molarity of HCl. So therefore, it is the titrant. NaOH, on the other hand, all I know is the volume. So therefore, that one is the analyte. Okay, so then what do you do for the titration process? Is you use a burette, which is, we've showed it in class, we did it with the IMF unit, where you're going to use a burette and we're going to add the titrant to determine the exact amount of unknown solution that is needed to have the equivalence point and the end point. And it'll come into play and you'll understand it a lot better when you actually do the lab. But basically what you're going to be doing is adding a liquid in the burette, which is this glass long tube, and you're going to be mixing with the solution in an Erlenmeyer flask of some sort. And what you're doing is you're going to be trying to get it where the end point and the equivalence point are the same. The end point is when you're going to add this indicator to it, okay? And what happens with the endpoint is when, in this class we'll be doing phenolphthalein. It's when it goes from clear to a pale pink. That is your endpoint, is when you see a change of color, okay? So phenolphthalein goes from clear to pink. And we're going to be actually having a palest pink contest. The equivalence point is when the number of moles of your titrant or your acid is equal to the number of moles of your analyte, which could be your base. You can switch them too. Your titrant could be your base and your analyte could be your acid. For this class, that's all we're going to be doing is acid-base reactions. So when does that occur? When your acids equal your bases, it's when you're neutral, so your pH will be about 7. So what you're going to try to do is have your endpoint change at your equivalence point, so you know that the pH changes at about 7. Okay, and then through stoich, you can just determine the concentration of the solutions. And that's what we've been doing through our solution stoichiometry. Here are the different parts of the burette. Sometimes you say it's with 1 T and sometimes it's 2 T's and an E. This whole system is the burette. This is known as your tip. This is known as your stopcock, this whole thing. And what you're going to be doing is looking on these different volumes. Notice that it starts at 0 on top, and you're going to actually go from the top to the bottom. So if I were reading this mark on here, I would read the sure one, which was 4, okay, and then it goes down to 4 point, I would say, let's say 8. So this would start at about 4.8 milliliters. And remember, you always go off of the meniscus, and it's reading it a little bit backwards. I guess what you want to kind of think of is how much error do you have? So in this case, I have 4.8 milliliters of air. And then what you're going to do is you're going to do the titration, and notice you have the indicator and it's going to be turning pale pink. And when you're done, what you're going to do is you're going to read your reading again. So let's say this was 4.8 and this is, let's say, 10.8. Okay, because this whole thing was, let's say, 10.8. So how much liquid did you add? You would just subtract it, because you know you ended up with 10.8 milliliters of air. You started with 4.8 milliliters of air, so you ended up with adding 6 milliliters of your solution. All right, so you will have to know these terms of burette, tip, stopcock, and also how to read the burette as far as the volume goes. And once again, the key to that is that it actually starts from the top and goes down. It's not from the bottom up. All right. Hopefully you have a basic understanding, and we'll practice this lots in class.